Okay, hello everyone. So we're gonna start briefly. So while we're starting, we like to launch a survey to understand your background for future references. Let me. So please answer the survey while we are making the introduction. So my name is Murat. I am Stanford scientist and Magnimind co-founder. And I worked on data science and AI. I've been working on data science at Stanford. I also teach in Santa Clara University machine learning AI classes. So we've been, as a Magnimind Academy, we've been holding our meetup groups for the last 5+ years. It's past 300 events. If you're not a member of any of our meetup groups, please welcome to join. And we have a YouTube channel where we have our recordings from previous events. We put our most meetup or events in YouTube channel, except some of those registered workshops. So you have to be registered our workshops to attend it, but most of our events there is very diverse, rich content. And we share all other our social media platforms. We provide different contents in each of them. So there are a few announcements we're going to have. First, we're going to have a 6 weeks LLM mini bootcamp. This is a rare event that we specifically designed for the industry's demands. And as you're filling the survey, we understand from people that most people look for job market, or most job market openings, they require LLM background. And we're going to build AI agents, and you're going to learn the deep understanding of LLM with Dr. Jaron, which I will introduce him. And Semi Hasaj, he's an engineer in C3 AI, and he's expert in LLMs, and he built LLMs for different big corporates. And also myself, I will also teach the LLM aspect, how to build products in LLM, or what kind of products you guys can build with LLM. So that would be good in intense 6 weeks program in LLMs. If you don't want to miss your spot and get early bird, it's finishing in 3 days. While you're registering, you have to finish and complete the purchase, otherwise you won't have a spot. And after 3 days, price goes up. That's a unique and rare opportunity. We don't know if we're gonna offer that again. So, but we have a regular our mentorship data science internship programs, 15 weeks, where we assign mentors to students. 4 to 5 mentors working on so many projects. Plus, we have a company affiliations we provide where students work with companies from industry. And then they get this experience, which most recruiters ask and demand. And if you have any questions, you can let us know. And then we're gonna give more information on that later. So I will introduce Dr. Jeran, and he is a co-founder in Magnimind Academy, and he's faculty in San Jose State University. Prior to that, he was faculty in Kaiser University in Korea and Santa Clara University. And he's also working on AI medicine projects with Stanford University School of Medicine. And he's been in data science and computational field in close to 20 years. He's a great person to learn data science in general, specifically LLMs and AI agents. So I will let Dr. Jeran start when he's ready to start.
All right, thank you. Thank you for the introduction, Dr. Murat. So hello, everyone. Welcome to another Magnimind workshop session. This time, we are going to work together on creating a simple AI agents step by step. So we're going to work on 4 different small projects. And then I'm hoping that you guys are going to work with me together. We're going to write the code together. You don't need anything except opening your Google Colab. That's it. So you don't need anything else. We are going to build everything from scratch together. I'll also give you the API for the LLM that we're going to use today. So all you have to do is just type the code with me together and then see what's going to happen. So before we start, I would like to share this tweet with you. So let me see if I can find it. First, let me share my screen. Yeah, I'll share my screen first. Okay. So this is from one of my favorite machine learning book authors, Sebastian Rachka. So the day before yesterday, I just saw his tweet. I really liked what he was saying. So job roles in 2027, 2026, I would say from 2025 to 2027. So data scientist is going to turn into analytics strategist. Before, a data scientist was expected to do cleaning data sets, structuring queries. Now it's going to be about framing questions and then interpreting outcomes. So that's mostly what I'm interested in. But if you guys are falling into any other category like programmer, so before writing code by line, after designing logic and structuring systems, I really liked the way he put the change in the job market into perspective. So that's the first thing I wanted to share with you. Second thing, before we get started, I wanted to share with you is a small side project I'm working on. So this is a very small AI agent running locally right now on my computer, and then I try to see what kind of tasks for jobs are going to be replaced, augmented by AI. So I would like to just look at data scientists, and then data scientists are related to so many different jobs. So I wanted to select data scientists. So this is running locally. I haven't, what is that? I didn't share this with publicly yet. So right now, an LLM running locally is analyzing all the tasks related to this job, and then again, depending on how I define different attributes of uh, uh, jobs that are going to be replaced or augmented AI. So this is not directly coming from LLM, but I also gave a lot of input, expert input into LLM to give me feedback on which tasks are going to be replaced or augmented. So I actually did this for many different jobs. What I see is in the next, again, this is not, it is not perfect. I'm not saying this is all 100% correct, but more or less, I'm working with another field expert on this. More or less, most of the tasks we're going to see for different jobs are either going to be augmented. I'm not saying totally replaced. That's I think too unrealistic, but it's going to be augmented by AI. In other words, we are going to be competing with our peers who know more AI. So they're going to be the ones that are going to be stronger in the near future. Okay, so that is another thing I wanted to share with you before we get started. Now, let's get started with our session. Please open your browser, and then if you could just, this is what we're gonna do today, okay? This is what we're gonna do today. If you could please open a new notebook in your Google Colab. Okay, so I'm gonna use Google Colab. Normally, I did all this work on my local VS Code, which is looking much more organized and professional, and it's much easier for me to push my code. But for this session, for the workshop, I found working on Google Colab will be easier for all of us because we need to install certain libraries, and then it's going to be easier if we all work on Google Colab. So if you guys are ready, we can start. If you need more time, please type your questions, comments, anything regarding this session to Q&A. Let me know if you need more time, but if you are ready, I'm going to start. So just open a new Google Colab Jupyter Notebook. That's all I'm asking. You don't need to title it now. Yeah, it's a blank screen, just a blank notebook. That's all. That's all you have to open. You don't see anything you don't see my screen. Can you not see my screen? It says blank screen.
Oh,
Can you guys?
with this screen, maybe he has to click on his own computer. Yeah.
Oh, okay. So but you guys can see my screen, right? Okay.
Yes, everyone see. Yeah.
All right. Okay. Thank you. Can see. Okay. I can see the screen. All right. Thank you. All right, so the first thing I'm gonna do is I'm going to install some libraries. So this will take maybe, what is it, a couple of maybe 35 seconds, depending on the speed. Okay, so here is what we're gonna do. We are going to use pip install, okay? So LangChain. So today we are going to use LangChain, Google, Gen AI. Okay, so that is first library we are going to use. And then LangChain community. That's the second one we are going to use. All right. And then we are going to use a vector-based database, face CPU from Facebook. Okay, that's the next one. And sentence transformers. That's what we need for one of the small applications we are going to develop. So please type this. These are 1, 2, 3, 4 libraries that we are going to use. So I'm going to run this cell. Please run this cell too. So it's going to install these cells for this session to your Google Colab. So next time you come, when you run this, you have to do the exact same thing. So it's only going to be installed for this session. Okay, so I'm running this. So it'll take a while, so maybe 30, 35 seconds. So you're gonna see a lot of yeah, lines of like requirements are set. So you're gonna see all these things. So don't worry. So it's just installing the what is that, libraries. Yeah. So my sessions were already running, so it's uninstalling and installing again. So in your case, this might be the first time it's installing. See, scroll up, please. Sure, sure. These are the, I'm going to, after I write every piece of code, I'm going to copy and then share it with you so that, okay, I'm going to share it with from the chat with you guys. So please just use Google Colab, okay? This one. Just use Google Colab. If there are any mismatchings, if the distribution found for sentence it's not found, so I have no idea about that error. So Aisha, so I'm sorry I cannot fix it now. So I don't have any suggestions how to fix it now. But on my end, this is what I'm gonna use. Maybe you can just follow the rest of the session and then try to do it later by watching the recording. Okay, so I think we are done. So it is done. So I'm just going to comment this out, and then I'm ready to start typing my code for, yeah, it was a type. Okay, so I'm gonna start typing my code for this session now. Okay, now the first thing is I'm going to import Google Generative AI, okay, from LangChain, Google Gen AI. We are going to use Google's Gemini LLM today, okay? So I'm gonna, because I already installed LangChain Google Gen AI, so from Google LangChain Google Gen AI, I'm going to import Google Generative AI. Okay, so that's what I'm gonna import now. So I'm done with this line. So now I have Google Generative AI imported. All right. Okay. So I'm just taking it slow now, just trying to see if everybody is settled and then they're ready following me. Because now I'm gonna give you the API for this session. This API will only be valid during this next maybe 1 hour or 75 minutes, then it's gonna be deleted. And it has a cap, so please just use it during the session for this session. Okay, so you guys are ready? Yeah, I will post yeah, that's what I'm gonna do. So I'm gonna post everything I write here so that you don't have to type it if it is taking too much time. All right, or if you guys have any mistypos. Yeah, this is recorded. The recording will be shared. But if you are already here, stay with me. Okay, let's do it together. Okay, so now I'm gonna share the API with you guys. So for that, what I'm gonna do is I'm going to write, I'm gonna say Google here, Google API key. So this is very important. This one is very important. So with this API key, we are going to get connected to a large language model. In this case, it's gonna be Gemini 2.5 Flash. So Gemini has multiple products. We're gonna use. We're not gonna use the Pro version. It was a little bit expensive, and then we don't need that now. I thought of running a free local LLM, but for this workshop, I think the first workshop, I think it's better if we use a paid LLM, so not running anything locally because we need to set it up for local connection. I didn't want to spend time on it. Okay, so what I'm gonna do is I'm gonna say input. So I'm just asking, I'm just making this more interactive. Okay, otherwise I can just API key. So this API key is going to be stored as a string. Okay, so I'm gonna run this and then it is expecting from me my Google API key. I'm gonna get my Google API key here and this one, I think I copied this. Okay, now I'm going to share this API key. Let me first enter it here. Okay, and then I will share it with you. So you don't need to use any other API key. You can just use this one for this session. Again, it's not going to be valid after this session. All right. Please let me know if you guys got the API key. Can we discuss deployment options in the file? Oh, so Adam, that's a different story. So maybe we can have another session for how we can deploy these models. For now, we are just building a simple 4 different applications. Right? Okay, I think we are good to go. Now, what I'm gonna do is I'm just going to see if this is working. Okay, so I will say Google generative. Sorry, I'm not typing here. Google generative AI. Okay, so that's what important. Okay, so Google Generative AI has multiple parameters. I'm gonna use two of these parameters. First, I'm gonna tell which model I'm using. So here is it. So there are different models, right? So where is it? Gemini API has no here. So I'm using Gemini 2.5 Flash. I'm using this model, okay? This model. So that's what I'm gonna use. So I'm gonna say this is Gemini, okay? 2.5 Flash. Okay, this is the product I'm using. And this product has a API key, Google API key is the key that we just entered, Google API key. Okay, so this way I am creating an instance from large language model. Okay, I'm connecting to large language model through the API, and this is an instance of, I'm gonna call it LLM. I'm sorry, not here. I'm gonna call it LLM. You can call it anything you like. Going to be LLM. I will copy the code and share it with you in a minute. Let me make sure that this is working. Okay. All right. So I will run this, and then I have a small typo here. Okay, so I connected to generative AI. I got LLM. So the next thing I'm going to do is I'm just going to send my first prompt. Okay, so I'm going to use for that invoke method. So I'm going to send my prompt and I will get the response back from Gemini. Okay, so I'm going to say hello to this workshop's participants. Okay, workshops participants. I say this one. Okay, and then I'm gonna get the response back from. Okay, so let's see. So I am sending this prompt to LLM and then waiting for the response. I got the response. Let's print this response. If you just say print response, I will share the code in a moment. Let me just run this. If you just say print response, you will see, hello everyone, a warm welcome to all our workshop participants. We're so glad to have you here today. Let's make this a productive and insightful session. So this is what Gemini is telling us. Okay, so I'll stop, pause here. Let me see if yeah, so Rupa, really, it's very difficult for me to check what is wrong with installing. So maybe you can just follow the rest of the workshop and then try it later. Okay, I'm sorry about that. Okay, so let me see. Yeah, is that a typo? Yes, yeah, Ratna, thank you. So I already typed corrected the typo. Okay, now I'm going to paste the code. So in case you were not able to write the code. Okay, first of all, this one. So I'm just pasting the code at chat. So another thing, another parameter for LLM is temperature. I didn't use temperature here. I use temperature, the default temperature. Temperature is another parameter that we use to adjust how much of randomness we are expecting from the response. So basically what LLM is doing is it's just predicting the next word, right? If the temperature is set to what is that? One, that means every time you send the same prompt, you will receive the same response. By changing the temperature, you are actually adding some randomness to which word is going to be picked next, as LLM is making its decision on which word it should pick next. So you are adding some randomness to that decision-making process. So in that case, every time you send the same prompt, the response is going to be different. Yeah. So, John, that's what we want to do actually. So I see your question. Why it did not give a lengthy response? So we have to be satisfied with whatever response we are getting from this LLM. Now we are going to write our code so that we are going to give him some hints on what kind of a response we are expecting from him. So maybe we are going to tell him that, can you make this response warmer and then longer? So that's what we're gonna do. So this is just the first step on seeing if our LLM is actually active. So are we being able to communicate with LLM? That's what we want to see now. Okay, and then let me copy this one too, and then share with you guys. All right, so this is the very first thing. This is just we're just checking if our LLM is working. Okay, if you guys are ready, let's turn this into a function, and that will be our first demo. So it's a raw AI, okay? I'm gonna call it raw AI. We are going to then work on this to make it more interactive. So we are going to actually steer AI to give us responses in the format that we want him to respond to us. So let me turn this into a function, and it's gonna look more professional, okay? So I'm gonna say, define my first function. It's very simple function. I'm gonna call it raw AI, okay? That's it. So there is no parameter for my function. It's a very simple function. So in this case, I will say, I will expect from the user a question, okay? So what is that question? Ask Gemini anything. Okay, so we are just gonna ask anything from Gemini, and then again, we are just going to use this LLM. Let's use response will be LLM dot invoke. You can already see the rest of the code, right, on the screen, but I'm typing it anyways, okay? And then I'm just going to print this, okay? I will use this. So let's go to the next line. Gemini is saying this. Let me make another, and this is the response. So I'm just going to the next line, okay? So that is my function. Now I'm gonna move outside, so, and then run my function, raw AI, okay? And let's see what's gonna happen. Again, the same thing, we are just asking some question. So I'm just curious about AI agents, okay? That's the first thing I'm curious about. So now we are getting the response, and see what Gemini is going to tell us about AI agents. Okay, so this is a very big question actually. So yeah, as you see, it's giving me a good explanation on actually, if you took any introduction to AI course, so you would understand, you would go through these terms very easily, right? So perception, action, environment. So these are all defining what an agent in AI agent should be doing in an environment. So then it's giving us types of AI agents, so model-based, goal-based agents, and examples of AI agents. So this, I mean, it's not deep, but it's just giving us a very short introduction to what AI agent is. Okay, so our goal is not learning about AI agent, by the way. We just wanted to see that we can make this work writing a function. Okay, so that will be our raw AI function. As I said, now we're going to work on this and then make it work better. Now, let's do this. Let's, instead of asking a single question, and by the way, let me check. Is invoke the standard chat messaging syntax with these LLMs? Yes, yes, Adam. So this is actually sending the prompt and then getting the response. So that's what we are using for. This is coming from LangChain. And could you post here the pip install code as well? I missed the beginning of this. Sure. Yeah, we are gonna be sharing the recordings later. So this is the pip install code I'm sharing with you. Okay, now let's do this. Let's rather than having a single question, we're expecting a single question from outside. Let's put a number of questions on a list. Okay, so and then we are going to what is that? Again, ask from our Gemini to answer those questions. So we want to make an observation here. Okay, so this is the list of the questions. So I'm gonna put my first question, explain machine learning. Okay, so I just want him to explain to me machine learning. So this is gonna be my first question. Tell me briefly, I think LLM will understand, even though my pronunciation is not good. Tell me briefly about machine learning. Okay, so these are all same questions that I'm telling in different formats. Okay, what is this machine learning thing? Okay, so I'm asking questions in different styles. Okay, so that's what I'm doing. Next, what I'm gonna do is I'm gonna make my LLM answer these questions one by one. So let's write a for loop, okay, for questions in questions. Okay, so I'm gonna pick each question one by one. So let's first write a print statement to indicate this is the question. Okay, so that we know which question we are getting answer for. Okay, so we are getting to the next line, and then this is the question. Okay, first let's see the question, then let's get the response to this question. Invoke question. Okay, let's not print everything. Let's print just the first maybe 200 characters, because the answer is too long, right? So I don't want to see the whole thing. That's not the point here. So let's get the response, but only the first 150 characters. Okay. All right. So what I'm doing is very simple. I just put the three questions about the same thing in a different style, and then I'm just sending these questions one by one to my to the Gemini, and then I'm getting the response. I'm only printing the first 150 characters of these responses. I just want to see if there is, if I'm gonna get exact the same responses or different responses. Okay, that's what I want to test. Okay. So this is the first question, explain machine learning. So we are waiting for the response. Again, we're gonna see the first 150 characters of this response. And it's taking time. Yeah, so imagine you want to teach a computer to tell the difference between a picture of a cat and a picture of, as you see, it just began to explain to me. And then the next, tell me briefly about machine learning. So machine learning is a subset of artificial intelligence that enables computers to learn. So what is this machine learning? Imagine you want to teach a computer to recognize cats and pictures in traditional pro. So I'm asking three questions about the same thing with different styles. I'm getting answers. You can see more or less the answers are saying same thing, but you can see that depending on the question, right? So the answers are slightly different. So this is just to test that you may see inconsistencies about the responses you receive, even though you ask the same question with different styles. That's the first thing. And second thing is, maybe I want AI to explain to me about machine learning in a certain style. For example, first explain it briefly, then give me an example, okay, and then tell me what is the role of machine learning in the future. Okay, so maybe I want him to explain any topic. It can be machine learning, it can be quantum mechanics, it can be blockchain. Okay, any topic. First, tell me briefly what this topic is about. Then give me an example and tell me how this is going to be impactful in the future. So if I want the AI to explain things to me in a certain way, so I need to tell this. So I need to tell this so that I will see consistency in the responses. Okay, so that's just an observation, nothing fancy going on here. Okay. All right. Now let's add some structure, okay, to our what is that coding. So this time we are going to interact with AI, but our interaction will be a little bit more structured. Let me see if there are any. Can you paste this in the question? Yeah, I'm gonna paste this code. Okay. I'm pasting that. Yeah. Okay. So what is the goal of this agent? Right now, there is no goal for this agent. This agent is a guru sitting on his chair and then answering any question asked to him. Okay, it's a very now right now this agent knows claims to know everything about anything. Okay, so then later we want to specialize it to a certain topic. All right, so that's what we're gonna do. All right, provide the function code. Yeah, I just provided it. Yeah, okay, let's continue. So now I'm gonna import some additional libraries from Google Gemini, okay, from LangChain, Google Gen AI, import Google Generative AI. Okay, I'm assuming we are all new to this field, so I'm trying my best to go slow. Okay, so and then if you are behind, let me know. If you need me share any of the code, let me know. Okay, prompts, import prompt templates. Okay, so you can understand from the libraries we are importing, we are still going to use Google Generative AI, but this time we are going to create a prompt template. Okay, so that is going to give some structure to the way we are asking the questions. And then the last one from LangChain core, okay, dot output. I have some other examples on this third one, but I decided not to do it today. So what we are doing now, this imported library, this third one is going to put the response, which is the output coming from LangChain, coming from LLM, to a certain format, okay? And then you can define this format yourself. Here, I'm not defining the format myself. I'm just going to use the format coming with the library, okay? All right, so let me run this and I'll share this with you too. Here, I provided the function code, but I'll provide it again. Oh, you mean this one? Sure. Yeah. All right. Now, if you guys are ready, we are here. We are going to build another application, a small application. This time, we are going to create a prompt which has a certain structure. Okay, so let's build a template for our the prompt, which is going to make LLM respond to us in a consistent way. Okay, so I'm gonna use prompt template. Okay, so this prompt template has certain parameters. First of all, what is the input variables? So the input variable is going to be, let me get to the next line so you can see this. The input variable, you can do anything here. So the input variable is topic. So in this prompt, one of the variables is topic. So the topic can be, again, AI agents, can be blockchain, or can be weather, can be a certain city. So it can be anything, okay? So that is a variable in our template. So let me go here, okay? Comma. So this is one of the first parameters of the template. The second template, now I'm gonna write my template. Template, okay? So here is the template. Explain. Now this is the prompt that I will give to the AI tool, but I don't want to write a specific topic here. So this topic is a variable, okay? Explain whatever this topic is. So when we create the prompt, that topic will change. We are going to define that topic. For now, I don't know what that topic is. I'm just giving a template so you can fill in empty spaces in this template based on what you want to say, okay? Explain whatever this topic in simple terms with an example, okay? So I'm not gonna stop here. I'm gonna even give further instructions. So here are the instructions, okay? The format is going to be as following. Keep it under 100 words. Okay, when you explain, use an analogy. Okay? And end with a practical example. Okay, this is what we want to see. So I'm going to give you the topic, and then here is how you are going to give me. Topic is this, which is topic. Okay, this is how I will see a response. And then here is the explanation. This is the explanation. And I am ending my template. Okay, so this is my template. Now I'm going to use this template. And then let me assign this template to a variable. Let's use prompt. So I'm going to use this template for my next. So prompt, remember prompt is the variable which is holding the template. Now I'm going to fill this template by, again, I have only one variable here. You may have many variables. You can add multiple variables here. I have only one variable. I just wanted to make it simple. So now I am going to fill in the empty spaces. Topic is AI agent. Okay, so that is my template. So this is going to be my field prompt. Okay. So I just used the template to create my prompt. And then let's see how this field prompt looks like. Okay, it looks something like explain AI agent. So I replaced topic with AI agent. In simple terms, with an example, blah, blah. Topic is AI agent, explanation will follow. Okay, now let's see. This is like a mail merge, right? So there is a template, there are infinite number of variations, and then we are giving AI formatting instructions. So this is going to ensure consistency across all responses we receive from the AI. Now, what I'm gonna do next is I'm gonna build a chain. Okay, I'm gonna call it chain. All right, so let me see if you have any questions. Can you paste it, please? I'm getting an error there. Question. Okay, so I'm pasting this one more time, this one. John, I'm pasting it here. On the chat, okay. I'm pasting that one more time. Okay. All right, so please let me know when you have any questions. All right, now I'm gonna build a chain. So now we are talking about LangChain, okay? So I'm building a chain. So this chain is going to first take my prompt. So imagine the order of things happening, okay? First, give the prompt, then connect to LLM and get the response, then format the response and give it as the output. Okay, so that's what I wanted. I want to do three things. Let me comment this out. First, give the prompt, then connect to LLM and get the response. And then I would like to format the response and give it as the output. That's what I want to do. So here it is. This is the prompt. This is the first step. So I'm going to connect these steps this way. So prompt line and then LLM. What is LLM? LLM is what we instantiated earlier, right? So this one, LLM. I'm using Google Generative AI, Gemini 2.5 Flash with this API key. So this LLM is our guy who is responding to us, okay? So we are asking these questions to LLM. Again, you can name it anything you like. My LLM, your LLM. Okay, that is the second step. And the third step is whatever response is coming, it's going to be parsed output in a certain format, parser. Okay, so first LLM is going to take the input. So we are going to fill the template, send this to Gemini. We're going to get the response. And then the response is going to be cleaned up. And then we're going to get the output. That's the order of things that will happen. So this is our chain. All right. So let's run this. Nothing is going to happen. So we just define the chain. Okay. Now what we're going to do is we are going to give three different topics and then we are going to get the responses to these topics. Okay, so let's do that. I'm gonna write a very simple code. Again, this time, these are the topics. I'm just gonna give different topics. Let's say blockchain, things that you are interested in. You can give anything, whatever you are interested in. AI agent, okay, and then what is that? Internet model. So these are things that I'm interested in. So okay, so these are the topics. Now let's go through the same for loop that we did earlier for topic in topics. Okay, again, I'm just going to print. I can see the code here. I'm just typing it anyways for us. Okay, so I will first print the topic explaining this topic. Okay, so this is the topic. Now, this is what's important, right? So I'm going to get the results by LLM. Sorry, not LLM. I'm not using LLM anymore because I already have LLM in this pipeline chain, right? So I'm going to use my pipeline chain. So I'm going to use chain. So that is the difference from the previous case. In the previous case, we were getting the response directly from LLM. Now I'm going to put my prompt through this pipeline. Okay, so through this chain.invoke. Okay, now the chain is going to get an input from us, right? What is that input? You look at the chain. Chain is receiving the first step in the chain is prompt. If we look at prompt, prompt is expecting an input variable from us. What is that? Topic. So here is the time for us to tell or give the chain what the topic is. That's what we're gonna do. Okay. So here is what we are going to say. This is topic. So this topic is the variable, this variable, okay? And this is the value for that variable that we are assigning, this topic. So this is maybe let me use a different name here so that we're not going to be confused with topic. For T in topics, topic is T, okay? So T is the topic name, topic is the variable name, okay? So I think that's gonna be better for us. And then let me take this, what is that response? First of all, yeah, let's just print it. Let's not make this longer. So I'm just going to say F response is the result. Okay, so let's see what's going to happen now, and then I will also share the code with you. Let's me first make sure that I don't have any typos. And there is typo. Explaining. Oh, this should be T2, right? So T and T are referring to this T, which is coming from this list. So I'm running for loop through this list, right? So T is elements of this list. Okay, let me run this. Yeah, so it's working. So now I gave the instructions, right? So first keep it under 100, or it should be keep it, use an analogy and end with a practical example. I'm just curious. Let's see what is said for blockchain. Response blockchain is a shared unchangeable digital ledger. Imagine a public diary where now it's giving me the analogy, right? Imagine a public diary where each new page block is cryptographically linked to the last, forming a chain. Once an entry is added and verified by the network, it's virtually impossible to alter. Okay, so this is the what is that analogy? Now let's see if it is giving a practical example. This centralization and transparency make it highly secure and trustworthy. A practical example is Bitcoin. Now it's giving us an application of blockchain, which is Bitcoin. That's perfect, right? So it just followed all the instructions, and then it kept with under 100 words, and we just structured the response we are receiving from our LLM. I think this was a simple but a good example. So let me copy this and share with you guys if you are falling behind in terms of writing the code. Oh. Yeah. So Janine, so it will be hard for me to to come up with the version numbers now. Uh, Again, yeah, I had similar issues. So I ran all these things on my other VS Codes, and then I had some compatibility issues. That's why I chose to use Google Colab. I thought it would be this, it will be the same for all of us. It will be much easier for all of us. Yeah. Could you please share the prompt? Oh, sure. I'm sharing the prompt too. Yeah, here it is. Okay, it's yeah. I'm seeing variance in response structures. Is an Adam, what do you mean variance in this? Yeah, so there is a change in the behavior structure, but this is the structure we are expecting, right? So it's exactly following other instructions. So just to see that we can control this large LLM is so nice, right? So we are making it follow a certain structure. Yeah, Kumal, you are going to receive an email from us on this session where you can see the recordings. Recordings will be available at YouTube channel, Magnimind's YouTube channel. Okay, let us continue. Now we're gonna do maybe what is that? Another example. Okay. So here we learned about creating a chain, and that actually helped us see a structured response from the AI agent. Now we are going to take one further step. Okay. Now, so at first we used the raw AI. Second, we structured our query. Third, let's say we want to build an agent using this LLM. Still, LLM is our guy, okay? It's waiting there for us to help. So he will always help throughout the session. He will always help to us. He will help to us. So now what we want to do is we want to work LLM for us, for our company. Okay. But for that, we need to give some information, some knowledge to LLM. So LLM doesn't know us. He knows uh, a lot about, in general, about companies, but he doesn't know specifically about our company. Okay. So it doesn't know about our company, but it knows in general what other companies are doing. So let's first try to see how LLM, our guy, is going to respond to this question. So I'm gonna again not to what is that not too different than what we did earlier. I'm gonna create a couple of questions for our LLM, but these questions are now specific questions about a company policy. Okay, so here are some questions. Question one: what is your return policy? What is your return policy? Okay, it's a very valid question, right? So comma question mark. Okay, that's the first question. Let's give the second question. What are your shipping costs? Okay, that's the second question. And third, make sure there was a comma here. And I'm gonna give a short break, okay, after this one. And then what are your support hours? You see, these are some valid questions that you can ask from any company, right? When you are making any transaction with them. Okay. Now what I'm gonna do is, and I'm gonna go through these questions again for Q in questions, in company questions. You are already familiar with this format, right? So we did this many times now. So I'm gonna say response is, I'm going to invoke, what is that? My chain. Remember the chain that we used, right? So this time topic is these questions, okay? Topic is these questions, but I mean, yeah, let's see how it's gonna work, because now actually I don't want it to use an analogy. It's not going to be. Let's rather than using the chain, let's just use LLM itself. Okay, LLM. I'm just gonna use LLM itself because it doesn't make sense to have any analogy for these questions, right? So let me use LLM. Okay, invoke. What is that? Uh, Q, right? Q. All right, and then I will just print the question, question, and then print the response. Let's get the first 150 characters again. Okay, so let's see if this is going to work. What is the this one, I think. All right, let's see what we are going to receive. Oh, we should have used yeah, it's not actually answering our question. So first of all, let me make this way. Just going to use this is this. Let's run this one more time. Oh, I'm just printing 150th character of the response. So that's why. Okay, I'll fix it. I'm gonna print the first 150 characters. So that's why you see we need to know how to deal with um, in this case strings, right? So I was just printing the 150th character. So okay. All right, let's see. Yeah, what is your return policy? Imagine you want to teach a computer recognize cats in traditional program. What is this? Oh, company questions. It is still taking the cue from previous case. Okay, let me fix this. Let's take a break now. I'm gonna fix this. I'm not gonna use Q here. So it's good. It's a good time to take a break. It's 10:02 during the break time. I'm gonna fix the code. So let's meet at 10:12. Okay, in 10 minutes. It's 10:02 my time. 10:12. We're gonna continue. Okay, we're gonna start in 3 minutes. So during this time, let me go through the questions. First of all, I just fixed that was a very simple mistake I was making. I just fixed the problem here. So we get the answers, but let's talk about this in 3 minutes. Uh, Getting an error on the first row, LLM is not defined. So we defined LLM at the very beginning, literally. So here, LLM, this one. So you need the Google API key for that. So this is the API key. I'm gonna share the API key one more time. This is the API key you can use for this session. It's not gonna be there in maybe 30 minutes. And this is LLM. This is how we define LLM. And so, yeah, notebooks. I can share this notebook. It's not a problem. Uh, Let me see how we can do it. So I can put this one to my what is that? Uh, GitHub account. So I think that's gonna be the best. Okay, so I can upload this to my GitHub account and then make it public so you can have access to this. But again, we are gonna have the recording anyways, so you can follow the recording as well. Let me see if we'll be recording. Yeah, could you explain briefly what LangChain is and what its relationship with LLM is? Thanks. So LangChain is a framework here. So what it is allowing us is creating structured prompts. So again, it's a lot more than that, but for now, that's the use of LangChain for us. We are creating structured prompts so that we can communicate with our large language model. So it is a way for us to communicate with LLM in a structured manner. Okay, let's put it that way. It's a lot more than this, by the way. How would you pass out the parameter from one step in the chain to the next? For example, LLM has more than one variables in the response. I'm trying to understand. So how do you pass output parameters from one step? Oh, yeah, you can assign your output to one of the variables to another prompt and then create a chain. Like you get the response from the previous question, but then the response to the first question will be an input to the next prompt. So you can create a chain of prompts, and each prompt is using the response to the previous prompt. Yeah, but again, this is the first time we are. I'm assuming that most of us are learning about this topic for the first time. So we are just navigating entrance, okay, entrance door to AI agents. Maybe in other workshops we can go deeper and then create more sophisticated ones. But these are very simple AI agents. We just want to see the difference between just communicating with ChatGPT versus communicating with GPT in a structured manner. Okay. Yeah, I think we are. What extra does prompt give over simply invoking LLM? What extra does prompt give over simply invoking? I mean, the prompt is set of the instructions, right? In addition to instructions, we can use the same template for many different topics. So for each question, I don't want to write a prompt. What I want to do is I want to use, in this case, I'm just explaining regarding this case, I want to use a template which is going to only replace, in this case, only topic, so that I can send the prompt to the LLM. Could you put the link to the collab here, please? JJ. For that, I need to share this one. Sure, sure, I can do that. I need to find okay, so let's do this. Just, I'm gonna stop sharing for a minute, and then in 30 seconds, we are starting again. So let me find the file in my Google Drive. Okay, just 1 second, please. Drive. Let me name this guy. Um, Workshop code June 28th, 2025. Okay. Um, just 1 second, please. Okay, I got it. So this is the link to this file. I'll keep this file in my Google Drive so you guys can have access to this file, okay? All right, let me share my screen now. All right, let's continue, guys. Let's continue. There is more to do now. All right, now what we're gonna do is, first of all, let's see what happened here. Okay, so I asked three questions. What is your return policy? What are your shipping costs? So my LLM, the guy that is responding to us, as you see, gave us very general answers, right? So as an AI, I don't sell physical product or services. I don't have a return policy. I'm here to provide. So there is no return policy because this guy is not selling stuff. As an AI, I don't sell or ship physical, so I don't have any shipping costs. So yeah, we are asking some questions, but these questions, LLM cannot answer them because I mean, even what are the support hours? So I'm available 24 hours, 7 days a week, but that is only the LLM itself. Okay, so but we want to ask these questions. We want to be able to answer these questions for our own company. Okay, so that's the next thing. What we want to do is we want to provide some input to our LLM so that LLM can use that input when responding to these questions. So that's the next thing we're gonna do now. So that is called RAG solution, retrieval augmented generation. So we are giving AI access to specific knowledge, and then it's like giving AI a handbook about our company. So AI is going to check that handbook before answering the questions. All right. So that's what we want to do. So first of all, that handbook, again, we're gonna keep it very simple. This can be very sophisticated. We're gonna keep things very simple. This here is our handbook. Okay. So we are going to create documents. These documents are this extra knowledge we are providing to LLM. So this is about our company. Okay. So I'm just gonna write this. We offer 30-day returns with receipts. Okay, that's our policy. Okay, second, free shipping on orders over $50. Okay, again, that's our second policy. Third, support available 9 a.m. to 5 p.m. Friday, Monday to Friday, Monday to Friday. So I'll talk about this in a moment. And then we accept all major credit cards. Okay, not paper. All right. So these are our company policies. Now, let's think how we can use these documents. I can build a small application. In this application, if a customer arrives at my application, at my website, and then wants to ask a question, the application will receive that question. So it's almost like input, right? So we are asking the customer, input, give me your question. Of course, we're going to say, please give me your question. And then what we can do is, given this question, we can check the words in the question. Let's say if in the words it's about returns, okay? I can simply, if, for example, if input is a question, take this question and then split it into words, and then check each word in that question. And then if you catch any words that are also in one of these documents, for example, the question is, what is your return policy? Right? So one of the words return is matching with this returns. That means the question is most likely about this document. I can simply report the first document. So what is your return policy? The answer will be, we offer 30 returns with receipts. So to some extent, that would solve the problem, to some extent, okay? Again, I take the question, I break the question into words, I go through the words in the question, and then I count how many of those words are actually, I do the same thing about these documents. I also break these documents down into words, and then I compare what is the overlap between the question and these documents. And the document that gives the most overlap, I'm gonna pick that document and then post it as my response. Okay, I can use an if-else statement for that. It's going to be a rule-based system. And to some extent, that might work. But let me ask you this. Rather than doing this, how about I tell you that take the question and then find the closest document to that question. Again, the logic is still the same. Get the question like, what is your return policy? But this time, rather than going through each word one by one, so if there was a way for me to compare this question with these documents, not word by word, but if I could represent these documents and the questions in terms of numbers, and then let's say one of them is for, let's say the first document. So I create, let's say, numbers representing these documents. Now my documents will look something like this. Okay, I'm just making it up. Okay, 4, 5, 1, 6. 4 is representing the first document. 5 is representing the second document. 1 is representing the third. 6 is representing the fourth document. And let's say question, whatever the question is. So what is your return policy? Question is also represented as a number, let's say. And then that number is, I'm just making it up. I am just making it up, okay? It is 3.9. Okay, again, how is the number is coming from? Why suddenly we are using number for a question? That we'll see in a moment. But what I'm doing is I take the question, what is your return policy? And that is mapped to some number. That is 3.9. Now I'm going to compare, I'm going to measure the distance between this number and all other numbers. So this time the distance is very easy, right? So what is the distance between 3.9 and 4? It's 0.1. What is the distance between 3.9 and 5? It's 1.1. So I'm just taking the difference between these numbers. So the smallest distance is 4. That means 4 is corresponding to this. We offer third-rate returns with receipts. Okay, that's the first novelty I'm bringing. Rather than counting the words, what I'm doing is I am mapping all the documents and the questions, all the strings into numbers. Here I used only one number, single number, a scalar, but I can use bunch of numbers. Actually, I can use, let's say, 150 numbers for any document. And if you ask me how, that's a different story. Okay, but let's assume that that is doable. That's the first novelty I introduced to this very simple application. Now the second one, rather than just saying we offer third-rate return with receipts. Yeah, we know that. The question is, what is your return policy? The answer is we offer third-rate returns with receipts. I also want now my chatbot, let's call it chatbot, respond more humanely. Like, thank you for asking this question. So we understand that you want to return your product, and we just want to let you know that we offer a third-rate return with receipts. Please make sure that you bring your receipt with you when you want to return your product. So what we are doing is we are actually answering the question, but when we answer, we are answering using this policy, but in a more humanly way, so that the other person is going to be pleased to hear that response. So that is the second novelty we want to bring. Okay, the first novelty is the way we are searching through the documents, finding the best document which we can use in our response to this question. Actually, that document and the question together will be a prompt we are sending to the LLM, and then LLM is going to respond using those two inputs. What is that? The document that is most related to the question and question itself. And then LLM is going to use these two to create a better response rather than simply saying we offer third-rate returns with receipts. It's going to be more, again, we can even check, control that, how the response is going to be, how long it's going to be, how it should maybe start with a greeting to the customer. Anyways, so that's what we want to do now. Okay, that's the next thing we want to do. All right, so let's get started then. The first thing is, let's talk about these numbers. We're going to call them embeddings. I'm going to write the word embedding. Again, this is a large topic. If you guys learn large language models, so this is a very important topic, embeddings. So how we create embeddings. Embedding is, again, coming up bunch of numbers, which is representing a document. Okay, and then we want to make sure that these numbers are for any document at equal length. Let's say I'm going to use 134 numbers or 300 numbers for any document. How we come up with numbers, as I said, that's a different story. Okay, for coming up with embeddings, I'm going to use Hugging Face. Are these what we call vectors? Yeah, embedding vectors, Adam. Yes, that's what we call. Yeah, I don't want to use so I want to keep it as what is it? Again, I'm assuming that we are totally new into this domain. All right, so I'm gonna use Hugging Face embeddings. There are many different libraries we can use or tools we can use to create embeddings. For this one, I'm gonna use Hugging Face embeddings. First of all, I'm not gonna run this one. Okay, so yeah, let me get to the next one. I'm gonna use embeddings. I will use Hugging Face embeddings. But before I use Hugging Face embeddings, I think I need to import it from LangChain.embeddings. Import Hugging Face embeddings. Again, embeddings will create these numbers for the documents. That's all it's gonna do, okay? That's what we expect. And then later I'm gonna use this database. This database is going to hold these embeddings. This database is going to, so for example, when I receive the question, how am I going to go and dig and find the closest response to that question? So I need to keep these documents after I find the embeddings for these documents. I need to store them in a database so that it's gonna be fast. So I expect a database that is going to be very efficient in terms of finding the closest embedding really fast. Okay, because I don't want people wait when talking with a chatbot, right? You ask a question, you don't want to wait for 10 seconds to get the answer, right? You want to get the answer right away. So I need something which works really fast so that when I receive a question, I find the embedding for that question and I find the closest the record from all the documents in my database. So for that, I'm going to use a database, but not for now. Okay, not for now. Okay, embeddings. Let me use this word correctly. Embeddings. Hugging Face. It's a small a. Embeddings. And I'm going to use a specific model. Again, these model names can change by time. Okay, this is all mini LLM L6 D2. Okay. All right, so let me run this and hoping that it's going to work. So we're just going to wait for loading it, okay? And then during this time, let me see if you guys have any questions. At the end, can you explain how to get our own API if you're experts? Yes, John, it's very easy. I got this Gemini API. Go to your Google, go to just type Gemini API. It's like 10 seconds. So you're just going to use your Google account to get API. Actually, you can get API for free. Gemini gives you free API. Use that for your exercise. Just keep in mind that it has a limit I think per minute there is the limit on number of prompts you can send. I didn't want to use the free one for this workshop because I don't want to stop in the middle. Right now the API you are using, I'll be paying for it, but it's not gonna be there in 30 minutes. But you can use Gemini API, free API, for learning purposes. And it's not going to cost too much. If you even pay, I think it's going to cost maybe $1, $2 for your entire week of learning process. Okay. Right, let me see. Paste documents, signing into with a different device. Okay. Paste documents to cell. Documents. I didn't get this. Oh, this one. Sure. I will post it. Edward, I understood your question. Okay. Should we use the updated model due to deprecation warning? Yeah, you can, but I'm not worried about it now. So you can always go back and then update your code. That is polishing your code. For now, I'm okay with this one. It's working. I checked this one I checked each one of these things before the workshop. It's working. Okay, so we got the embedding. Okay, we got the Hugging Face embeddings. I have it here. So now let's see what embedding means actually. Okay, so what I'm gonna do is I'm just going to do a very simple example. So I'm gonna give some sample text. Sample text. I'm sorry, sample texts. These are the sample texts. Return policy. Okay. Now we are getting into application, right? Refund policy, something concrete. And believe me, it's not going to take too much time for you to learn and implement this locally. Now, deploying it as an application for business, you need to spend some more time on that. Okay, so this is sample text. So what I'm gonna do now is now I already have embeddings, right? So I'm gonna use embeddings. Okay, so this instance again, you can give any name here. My embeddings, your embeddings. I'm gonna use embeddings dot embed documents sample text. Okay, so and then I'm going to assign this to sample embeddings. Okay, let's see. Let me run this and then sample texts. Okay. All right. It's very fast. I got the embeddings. Now I'm just going to show you the text length and embedding length. Okay, so let's write a list comprehension for this one for text in sample text. Okay, for text and sample text, I'm just going to have length of text. Okay, so this is, I'm just counting number of characters. So this one is, what is 5, 6, 11, right? I can see that. Okay, let me print this. This is the length of the text. So return policy is 13, refund policy is 13, weather forecast is 16. Okay, now I'm gonna do the same thing for sample. Let me copy this, paste it here. So I'm going to use EMD, embedding in sample embeddings. And by the way, there is a typo here, embeddings. Okay. Print the length of each embedding. You got it, right? So that's what I was trying to say. So the text, no matter how long. So now I'm going to return policy. You see, the length of the text is 13, 13, 16, but I'm using a standardized size of numbers representing these texts. So the first text is represented by 384 numbers. It's a vector of numbers. The second one, refund policy, is represented by 384. The third one is represented by 384. Each of these are represented by a vector which has 384 numbers, elements in it. So I can return policy for purchased goods from our store. You see, I made it even longer. So let's see. Now I have 48 characters in the first text, but still embeddings will remain the. So embedding changed. Embedding for the first text already changed, but its length is standardized. It is, so that's the beauty. No matter how long the document is, I will always represent every document with the same length of vector, in this case 384. So these vectors are not random numbers. That's why it is beyond the scope of this workshop. The way we come up with these numbers is also special, so that, for example, one embedding, if it is representing, let's say, king, okay, another embedding is, let's say, representing queen, okay, so queen, not queen, queen. Let's say these are two words, king and queen. I have embedding 1 for king, embedding 1 for king, let's say. I have embedding 2 for queen. Let's say I also have embedding 3 for man, and embedding 4 for woman. Okay, so here is the nice thing about these embeddings. The way they are generated is not random. Again, this is an example which we need to check, but more or less this is what's going to happen. So what I can do is I can take E3 man, and then subtract woman from man. Okay, E4. So this is giving me the difference between man and woman. Okay, and then when I add this to queen, E2, you see queen and king, woman and man. I'm taking difference between man and woman, adding that to queen. So this is going to give me a number which is very close to E1. You got it, right? So what's happening here is these embeddings in the space, they are vectors, are computed such that they are also representing the distance between the meanings of the words. And it's not just words, it's meanings of bunch of words, meanings of documents, okay? The content of documents. So that's how I'm gonna use embeddings. When I receive a question, I'm gonna find the closest answer to that closest document to that question by comparing their embeddings. Okay, let me stop about embeddings. Okay, let me continue with the code. Okay. Yeah, and then I really sorry. So yeah, you might receive these exceptions. I don't know what is the cause of the error now. So just please follow the workshop, and then maybe you can try later on. I shared the collab with you guys, so you can check it. Okay, let's finish this. We don't have too much time. How to know where to embed and give it number? So that's John. That's beyond the scope of this workshop. Okay, how we can get these embeddings. You can go back and then study a little bit on how we create embeddings for words. It's one of the first initial topics when you learn NLP or large language models, right? Okay. Now let's really write the application now. Okay. All right. So this time I'm going to use, as I said, I need to use a database, LangChain vector stores. I'm going to stop in 15 minutes, okay? Phase. So phase is, what is that? A database which is going to hold our documents. Another library we're going to use from LangChain a schema actually for documents. So we are going to create documents in a certain way, and then we're going to use these documents in our database. Okay, so let's use this. All right. Now remember our documents. Remember the documents we created. We offer third array return with receives. So we are still there. Okay, we are still there. So now I'm gonna turn these documents to a specific format. So I'm gonna use list comprehension for documents in documents. Okay, so I'm gonna take each document and turn it into a document format. Okay, so documents, page, content. Basically, this is creating. This document is just a string. It is going to put that string into a document template. Okay, so there is a metadata defining how a document is going to look like. Okay, we are actually creating a document, filling a document template where we're gonna use it to push it into our database. So our database is expecting documents in a certain format. That's what we are doing here. Documents. So I'm getting each and every document from my document list and turning it into a document format. And then I'm going to assign this list of documents to this variable. Let me print documents on the screen, see how they look like. You see? So I just changed, I didn't change too much, right? So I just took this string, but now I have a specific format. So the document metadata is empty. Again, this is a very basic, what we are doing is very basic. And this is the content of the document. So you can also define the metadata for the document. So we are not there yet. All right. So now this is a format which our database is going to accept. Okay, now I'm gonna take my database, and then it's going to take from these documents. Okay, all right, and then documents, comma. But before these documents, I need to create the, what is that? I need to also give the embeddings. This one. What is embeddings? Let's see. Embeddings is the name of the. It is the embeddings object. Just remember this. Hugging Face embeddings. So this is. Think of it as a box. From one side you put your documents. From the other side you get the embedding for that document. So this embedding is that box. So what we are doing is, to our database, we are giving the documents and the box. Okay. By the way, I should be consistent with the name, embeddings. Embeddings, yeah, correct. Okay. So the database is going to take our documents in a certain format. It's going to take the embeddings box, which is going to create embeddings for the documents. It's going to push the documents through that box. It will get the embeddings, and then it's going to store those embeddings for those documents nicely. Okay, let's put it that way, so that later on we can have access to these embeddings easily. And that, let's call this vector store. Okay. Now let me run this. Okay. Now, if you want to see how this is working, first of all, vector store. Let's see what we're gonna see. It's not gonna give us anything. It's just saying that vector store is an object, something that is stored at this address. Okay. So we're not seeing the content of that database. All right. So, but that database is created and it is somewhere stored in the memory. Now, let's test this. Let's test this. For example, I'm gonna run a query, test query. Okay, and refund policy. Remember, one of the documents is what is that? We offer 30-day returns with receipts. So this is the question. Refund policy. What is your refund policy? Now, here is how it's gonna work. I'm gonna take my database. Remember, our database already has this box, embeddings. Okay, so I'm gonna take, and then I'm gonna ask my database, can you search for similar search? Can you search in your database? Can you search in your records for similar things to this test query, refund policy? Okay, let me put this inside, test query. So what this vector store is gonna do is, it's gonna take in this refund policy query, it's going to push that query through this embeddings box, and it will receive the embeddings for this query, refund policy. It will find the embeddings value, embeddings vector for refund policy, and then it's gonna compare that embedding with all the embeddings in the record. Okay, so how many embeddings we have? 1, 2, 3, 4. There are 4 embeddings in the database. It's gonna find the embedding for refund policy. It'll compare. It'll find the most similar. Here we're gonna say, give me the most similar one document. If I say 2 documents, it's gonna give me the most similar 2 documents in order. I'm gonna say give me the most similar document to this embedding. Let's see what it's gonna return. Okay, so let me run this. You see, so it already returned the ID of that document, its metadata, and its page content. Okay, so let's make this, let's make this more, put in a more nicer format. So I'm gonna say this is my relevant. You got what's happening here, right? Relevant documents. Okay, so you got the rest of. I asked refund policy. It easily found the most relevant document to this question. I didn't search for words. Remember, that was our if-else rule-based system. We will break down the queries and the documents into words and then find the word frequency matchings. We didn't do any of that. We turned everything into a set length of vector, 384 long vector, and then we just compared those vectors and then found the closest vector to refund policy vector. That's all we did. So let's make this a little bit nicer. So I'm gonna print what is that? Relevant document. Yeah, you guys must be tired now. So I will get the first element, and then from that I'm gonna get page content. So this is a list. As you see, this is a list. This is a list. So there is only one element here because I asked only the closest one document. I'm taking the first document in that list, and the first document's page content. Okay, dot page content. Okay. All right. What happened? Page content. Relevant documents 0, and then page content. Relevant. Oh, I need to put F in here. Sorry. Yeah. So we offer 30-day returns with receipts. Perfect. So we got the most relevant document to our. Now let us create our, what is that? Agent, AI agent. So this time, what we're gonna do is, now we understood that we can have a list of documents that is only known to us for our own organization. LLM doesn't know those documents. LLM has a generic idea about the world, okay? But we want to create prompts for large language model that is going to be about our own company documents, okay? And then we want to, when we receive a question, we want to find the most relevant document from our database. And then we're gonna put this question and document together, put into a prompt, send it to LLM and ask LLM to give a nice answer using these two documents. That's what we're gonna do now. And then I'll finish with that. I have one more application, but I think we are out of time. So, and then I see that you guys also are getting tired. Relevance of K plus, what is K equals 1 referring to? So if I make this K equals 2, I'm finding from this, I have 4 documents. When K equals 1, I'm finding out of these 4 documents, I'm finding one document which is the closest in terms of relevance to refund policy stream. If I make this 2, then I'm gonna have, I'm gonna have 2 documents, right? Actually, sorry, let me print here. Relevant documents. Let's not change this one. Okay. Let's run this. Relevant documents. Now you see, I have 2 documents because I changed this. So these are the 2 documents that are, in terms of relevance, closest to this question query, refund policy. Okay, that's what it means. High similarity is shortest vector path. Yes, the shortest, we are just measuring the distance between 2 vectors actually here. It's gonna be cosine similarity, Adam. More technically, it's a cosine similarity. We are looking at the angle between 2 vectors. So if 2 vectors are closer to each other, cosine of that angle will be the smallest. You're welcome. Not tired. Okay, why? So wow. All right. So let's finish this, guys. Let's finish this one. Now let's create our new application. All right. Okay, let's see. So let's write this as a function together. So this is the RAG. So
Dr. Jerome, maybe before you start, I make the last announcement.
oh, sure, please go ahead.
Okay, sorry, just give me time. So I hope you guys enjoying. I see that participants level is almost 98% from starting. It means that people really enjoy. We are over 100 people here. So if you want to continue on excelling LLMs, which most jobs are really looking that skill set, LLMs and AI agents, So that 6 weeks program we mentioned in the beginning, we have actually a early bird discount till end of the month in couple days, 2 days, and it is $500. Original price $800. We recommend not to miss it. Not only early bird discount, we have a limited space. We may close the registrations in after maybe 2 or 3 days. Just encourage to register if you want to get more in depth, and you will be also joining Magnimind alumni, where we also offer special classes to just alumni only. So thank you, Dr. Jirang. So
Thank
you
you.
may continue.
Thank you. I just want to add, my colleague Semi is an MIT graduate. He's really good at what he's doing. He's actually working in the Silicon Valley. He's an expert on this, so he will be giving half of that workshop, and then I'll give the other half. So just for information. Okay, so let's continue. Let's now write the function, which is going to be our application. I'm gonna call this ask. I'm sorry, here. Ask rag. So this time I'm gonna create an application which is going to receive a question, okay, from outside. And then exactly we are gonna look for the most relevant document to that question. And then we're gonna send question and that most relevant document to our LLM. And then we are going to get the response to that. So let's see how it's gonna work. Let's see how it's gonna work, okay? First, so we are going to find the relevant documents. So relevance document. So we already document, I'm sorry, document. We already have our vector space here, vector store. I'm gonna use the same vector store. Otherwise, we should have put this inside the function. I'm not doing that. So, and then I am searching for similarity search, okay? And then I will say, I'm looking for similarity search for this question. Let's set K to 2 this time, okay? So earlier it was 1. Now I'm looking for the most relevant 2 documents to this question. Okay, so next what I'm gonna do is, sorry, next, if you like, you can print those documents on screen if you like, just to, if you wanna see how they look like, but let's not do it. We already did that part, printing the content of the documents, we already did that. Now, I'm gonna put these documents, join them together, and then create one context from that, okay? So for that, I'm going to first create a, use a, what is that, list comprehension for documents in relevant document, okay? I'm gonna put these documents together. So for that, I will get the, first I will get the page content of each document. I'm sorry, page content. You know what this page content does, right? Here, page content. It's just from these documents. So this is the document. Okay, let's say this is the document, the most relevant document. I'm only taking the page content part of that document. This 30-day, we offer 30-day return with receipt. I just take that part. Let's say I have 2 documents. I take that part of these 2 documents and create a list of that. Okay, so actually, let me run this here for you, this one. So let me first print this. I just want you guys to see what I'm doing inside the function. This one. That's exactly what look, this is the 2 documents. The first list is the 2 documents. Second is only the list of the document content of those 2 documents. This one, the second list. That's what we did here. Now, next, what I'm gonna do is I'm going to join them. So let's see how it's gonna work. So I will join them. Like I'll put first document content and I'll put the second one right below that one. For that, you know the join function, right? So what I'm gonna do is first I will write a string. That string is /n. /n is going to go to the next line, right? So I will join these 2 documents using /n. That's what I'm doing. That means in between these 2 documents, I will put /n. So let's show what I need this one. Okay, here you see this. I put in between 2 documents. I put this /n. Basically, first I'm just telling that this is the first document content. and this is the second document content. I'm just creating the context for that. So let's do this. /n dot join. Perfect. We don't know to do this. We don't need to do this, but it's gonna be easier if we join all the documents and then call it a context. Okay. Now let's create our prompt. We are experts of creating prompt, right? We already did that earlier. We're gonna follow the same steps. So this is my prompt template. We know how to create a template now. In between this, I'm gonna write my template. Okay. So based on this company information. Okay, so this is my instructions to LLM. Take this context. Now this context is coming from here, right? That is the input to our prompt. And then take this question. Okay, take this question. And then this is my instruction. Please provide a helpful answer based on the company information provided. Okay, and then answer. You see, this is my template. Perfect. Next. Now, this template is going to receive context from here, question as the function parameter. Okay, all right. All right, now I'm gonna get the response. Response is LLM.invoke. Here, if you like, you can create a chain too. Remember, we created a chain. Now let's keep things simple for now. Let's see what is the response. Okay, and then I'll get the prompts. Rag. Nothing stops us from creating a chain here. I just don't do it here for now. And then return response. That's it. So I just created a very simple RAG application. Okay, so let's test it. Question. This is what the person is going to ask. What is your return policy? Okay, now let's get the response. Answer. I will ask my AI agent, hey, give me the answer for this question. Now let's print this answer. Okay, let's see if this is going to work, guys. If it works, we are fine, okay? Let's see. And most of the time it doesn't work. The first try. Oh, it did. You see, it says we offer 30 returns with a receipt. So it is we offer 30 returns with receipts. It just added a receipt. So it was a very so we can add please provide helpful answer provided please. Okay, let's do this way, please. And then first greet the customer, say a few nice words. Okay. Hello there, we're happy to help you with your question. Our return policy is quite straightforward. We offer 30 returns for items when accompanied by receipt. We also accept all major credit for their convenience. Perfect, right? Perfect. So just imagine that these documents are not just simple list of sentences. You can have actual documents, really long documents, right? And each of these documents are going to be squeezed into a fixed length of vectors. And then they will be stored in a database, which is going to allow you to search for them very quickly. And then you can turn any question into a vector, and you can find the most similar vectors from your vector space. And then you can send those documents with the question to your LLM, and then LLM is going to get back to you based on your instructions. And we also learned how to create a prompt, a template for a prompt. I think this was very useful. So I had one more application that I was planning to share with you today, but I think we did good today. Maybe next time. All right. Thank you so much for listening. Our time is up, and hope to see you guys in another workshop. All right. So I shared the document with you. I will close API right away. So that means you need to come up with your own API to make the code work. Otherwise, you're gonna receive that the API key is no longer valid. You're gonna receive that kind of a response. Okay. Thank you and take care. See you next time.